So this simulation allows you to simulate the tides. What you see when you open the simulation is here's the Earth, this over here is the moon, and this red patch around it is showing what the water on the Earth is doing. So you can see on the line connecting the Earth and the moon through the centers, you get a large bulge of water in the direction of the moon and a large bulge of water away from it. This explains why we have two high tides. It really comes down to the fact that the force on the water on this side of the Earth, the side of the Earth nearest the moon, is larger because it's closer to the moon, therefore it is pulled outward or attracted more to the moon, while on the other side it is far enough away that the force is low enough for it to be smaller, and therefore it is not attracted as much and isn't pulled tight up against the Earth. If we click run, we see that the tides follow the orbit of the moon around the Earth. Now I'm going to stop it for a minute. Now, right now you can see, let me start it again. You can see that the Earth is indeed rotating, but we're not including the effects of the Earth rotation. So now indeed I will stop it. I'm going to include that and watch what happens. See how it shifts? Oops. What I want to do is click and unclick. Okay. See how it shifts? And notice it shifts in the direction that the Earth is spinning. Okay. So now if I stop it again, if you look, the high tide line isn't on the line that connects the center of the moon to the Earth center. It's shifted in the direction of the Earth's rotation. I think about this as the blender effect. The Earth is kind of acting like the blades of the blender and pushing the liquid ahead of it, and therefore they get shifted into the direction of the rotation. Okay. So I'll let that run again and let you look at it for a minute or two. Now, certainly the moon is the big cause of the tides on the planet, but it's not the only thing out there. Another big player in our tides is the sun. So let me include the sun. In this simulation, the sun is assumed to be this way. So if you look, the lit part of the moon always faces the sun, as does the lit part of the Earth. Right? And I'm going to get rid of the effects of the rotation for a minute. And if you watch as the moon goes around, sometimes the bulge of the water away from the planet is really big, and sometimes it's smaller. And it's really a question of what is the orientation of the moon and the sun. So if I stop it right about here, it should have been more perpendicular, but that's okay. That gave us the smallest bulge, if you will. Everything's kind of uniformly distributed around. Because the sun is pulling the water one way, the moon is pulling the water the other way, and therefore it kind of washes out. Okay. If we click run again, the moon will come around. You can see the tides are getting bigger and bigger and bigger. And when the moon is on the same side as the sun, these should be as big a tide as you can possibly get. And now it's because the moon and the sun are pulling in the same direction. So you may have heard along the way somebody talking about a neap tide, or a really, really high tide. A neap tide is what I said there. That's because the moon and the sun sometimes work together, sometimes they don't. I'll let you watch it go around a little bit further, and then I will be done with this simulation.